Hello everyone. In this video, we'll discuss about the torque ratios in three-phase induction motor. We have three different torques. One is the starting torque, another one is the maximum torque, and full load torque. So first, we'll discuss the ratio between maximum torque and full load torque. Okay, ratio between maximum torque and full load torque. Suppose SF is a slip corresponding to full load torque. Okay, slip at full load torque. We can write the full load torque as SF into E2 square R2 divided by R2 square plus SF X2 whole square. So we have already derived the formula for torque in the previous videos, right? So let this be equation number 1. So now we'll write the equation for maximum torque. So let Sm be the slip corresponding to maximum torque. Okay, so this maximum torque can be written as Sm into E2 square R2 divided by R2 square plus Sm X2 whole square. Let this be equation number 2. Okay, so now we will divide equation 1 by equation 2, that is full load torque divided by the maximum torque. So full load torque is SF E2 square R2 divided by R2 square plus SF X2 whole square. Okay, so this whole term will be divided by Sm E2 square R2 divided by R2 square plus Sm X2 whole square. Okay, so now if you want to divide these two terms, this numerator term can be multiplied by the reciprocal of the denominator, as we all know. So this can be rewritten as SF E2 square into R2 divided by R2 square plus SF square X2 square multiplied by the reciprocal. Okay, R2 square plus Sm square X2 square divided by Sm E2 square R2. So this E2 square and R2 will get cancelled. So the remaining terms will be SF divided by Sm. Okay, here we have SF and here we have Sm, and multiplied by the remaining terms R2 square plus Sm square X2 square divided by R2 square plus SF square X2 square. Okay, so now we are taking this X2 square outside from both the denominator as well as the numerator. So this can be written as SF divided by Sm into X2 square taken outside. So remaining terms R2 square by X2 square plus Sm square divided by, similarly we are taking X2 square from the denominator term outside. So X2 square R2 square divided by X2 square plus SF square. Okay, so now this X2 square and X2 square will get cancelled. So the remaining terms will be SF by Sm R2 square by X2 square plus Sm square whole divided by R2 square plus X2 square plus SF square. So now we know that Sm, the maximum slip corresponding to maximum torque, is given by R2 by X2. So in place of R2 by X2, we can substitute Sm. Okay, so now this can be written as torque full load divided by maximum torque is equal to SF divided by Sm multiplied by, so in place of R2 square by X2 square, we are substituting Sm square, here Sm square, and we have another Sm square. Okay, divided by, here again Sm square plus SF square. Okay, so plus Sm square divided by Sm square plus SF square. So this can be simplified as SF divided by Sm multiplied by, in the numerator we have 2 into Sm square, in the denominator we have Sm square plus SF square. So here one Sm will get cancelled. So the remaining terms will be 2 into SF into Sm divided by Sm square plus SF square. So this is a ratio of full load torque to maximum torque. So next we'll derive the ratio between starting torque and the maximum torque. So starting torque, slip corresponding to starting torque will be 1. So this starting torque can be written as E2 square into R2. In place of S, we are substituting 1. Okay, E2 square by R2 divided by R2 square plus X2 square. Okay, let this be again one equation. And we all know Tm is equal to Sm E2 square R2 divided by R2 square plus Sm into X2 whole square. Okay, so let this be equation number 2. Okay, so again we are going to divide these two equations so that we will get the ratio of starting torque to the maximum torque. So this starting torque is given by E2 square into R2 divided by R2 square plus X2 square. So now for dividing this maximum torque, we can multiply it with the reciprocal as we have already discussed. So R2 square plus Sm square into X2 square divided by Sm into E2 square into R2. This E2 square into R2 term will get cancelled. So remaining terms will be 1 by Sm multiplied by R2 square plus Sm square X2 square divided by R2 square plus X2 square. Okay. So now we can take this X2 square term outside from both numerator as well as denominator. So in the numerator, if we take X2 square outside, the remaining terms will be R2 square divided by X2 square plus Sm square. In the denominator, if we take X2 square outside, we will have again R2 square by X2 square plus 1. Okay. So now this R2 square plus X2 square can be written as Sm, and this X2 square and X2 square will get cancelled with each other. So now 1 by Sm into Sm square plus Sm square divided by Sm square plus 1. So this is equal to 2 into Sm square divided by Sm into 1 plus Sm square. So 1 Sm will get cancelled. So remaining terms will be 2 into Sm divided by 1 plus Sm square. So this is the ratio of starting torque to the maximum torque. Okay. Now let us solve one numerical. So the given problem is a 746 kilowatts 3-phase 50 hertz 16 pole induction motor has a rotor impedance of 0.02 plus j 0.15 ohm at standstill. Okay. So this is R2 plus jx2. Okay. So next full load torque is obtained at 360 rpm. So this is a speed corresponding to full load condition. So now we have to calculate first one, the ratio of maximum to full load torque, speed at maximum torque, the ratio of maximum torque to starting torque. Okay. So first we'll write the given data. So here first 50 hertz frequency is given. Frequency f is equal to 50 hertz. So next number of poles p is equal to 16. And the rotor impedance, that is R2 plus jx2 is given. So R2 can be written as 0.02 ohms and x2 can be written as 0.15 ohm. So these two are under standstill condition. So under standstill condition means S is equal to 1. Okay. So next speed corresponding to full load condition is given 360 rpm. So first we have to calculate the ratio between the maximum torque and the full load torque. And second one, we have to find out the speed corresponding to maximum torque. So the M represents maximum. So next third one, the ratio between maximum torque to starting torque. Okay. So first and foremost thing what we have to do is we have to find out the synchronous speed ns. So synchronous speed is given by 120 f by p. So 120 into 50 divided by 16. So this will be equal to 375 rpm. Okay. So next we have to find out the ratio between Tm and TFL. So we have already derived this formula. Okay, so the formula is Sm square plus Sf square divided by 2 into Sm into Sf. Okay, so Sm is nothing but the slip corresponding to maximum torque, and Sf is nothing but the slip corresponding to the full load torque. Okay, so first we will find out Sf. So Sf is given by Ns minus N full load divided by Ns. So Ns is nothing but the synchronous speed. We have already derived 375. N full load is the speed corresponding to full load condition that is given. Okay, 360. So again divided by 375. So this will be equal to 0.04. So this is the slip corresponding to full load condition. So next we'll find out the slip corresponding to maximum torque. So this is given by R2 divided by X2. So R2 is 0.02 and X2 is 0.15. So the slip corresponding to maximum torque will be given by 0.133. Okay. So now we'll substitute in the formula Tm divided by TFL. So Sm is 0.133 whole square plus Sf 0.04 whole square divided by 2 into 0.133 into 0.04. So on simplification we will get 1.82. Okay, this is the answer. So now we have to find out the speed corresponding to the maximum torque. So this is given by 1 minus Sm into synchronous speed. So this is 1 minus 0.1333 multiplied by 375. Okay. So on simplification we will get the speed corresponding to maximum torque as 325 RPM. Okay. So next one, what we have to find out is the ratio between maximum torque and starting torque. Okay. So the ratio is, the formula is given by 1 plus Sm square divided by 2 into Sm. Okay. So this will be equal to 1 plus 0.133 whole square divided by 2 into 0.133. So on simplification we will get 3.817. Okay. So this is a required answer.